Okay, students, we're going to go over Mod 2 Top 2, Lesson 5. There's several things in here. That's why I'm making a video. For those that might not be able to keep up in class, you can watch this video. Okay, so the first one is arc addition postulate. Well, I should recognize I have an addition postulate theorem here. Well, what other addition postulate theorems have I dealt with? I've dealt with segment addition postulate and angle addition postulate. And now we just have arc addition postulates. So you should always be reminding yourself of the different addition postulates that we've already dealt with. So all this is saying is, say this is 30 degrees and this is 40 degrees, which therefore makes the measure of arc AB 30 degrees because we know it equals its central angle. And the measure of arc BC is 40 degrees. That means that the measure of arc AC, when I add those two together, two adjacent arcs, arc AB plus arc BC are adjacent arcs. Remember, adjacent means next to. It just equals the sum of those two arcs, which then is 70 degrees. That is it. All right, next one we have inscribed angles. We talked about inscribed angles versus central angles before. You've been tested on it. Inscribed angle, remember, has its vertex on the circle. I've given you this information before that any inscribed angle equals half of its intercepted arc. So let's say this is 150 degrees from A to B, then this angle is, the inscribed angle is half of it, 75 degrees. Or if I started with that being 75 degrees, I know I double that to get this intercepted arc, which makes the intercepted arc 150 degrees. Okay, so that's the inscribed angle. So that's for all inscribed angles. Okay, next we have the inscribed right angle slash or dash diameter theorem. What that says is if I connect any inscribed angle at the ends of a diameter, that's going to be 90 degrees because the intercepted arc every time is a semicircle or 180 degrees. So that's 90 degrees. If I go ahead and draw it right there, it's still connected to the end of the diameter. So that's 90 degrees. If I draw it right here, connected to the end of the diameter still, again, that makes that 90 degrees. So it's going to be 90 degrees every time that inscribed angle connects the ends of a diameter, again, on the test. All right, inscribed quadrilateral. Again, you see the word inscribed. That means the vertex, all the vertices must be on the circle itself. And so the inscribed quadrilateral theorem, here, says the opposite angles are supplementary. So if this is 80 degrees, then this must be 100, its opposite angle. Supplementary, everybody should know what supplementary means. We've talked about that word over and over, two angles that add to 180 degrees. And so if they tell me this angle is 105, 105 from 180 is 75. That would make angle D 75 degrees. Now, using that information, just so you know, and of course all quadrilaterals add to 360, so if I added all those angles up, that would add to 360. Using the prior one that we just talked about, if that's 105, then this arc from there to there is double that inscribed angle. So this would be 210 degrees. 105 doubled. Just like that 75 goes from there to there, that makes that 150 degrees, doubling the 75. And notice 210 plus 150, because that covers the entire circle, is 360 degrees. That same thing would work on the other two. You'd have a 200 doubling the 100 and a 160 doubling the 80, and 200 plus 160 is also 360. Okay, so that's just using that as well. Next, we have the interior angles of a circle theorem. So interior angles means it's not a central angle. Remember, central angle has to be connected to the center. These are not. So here, let's just put in letters A, B, C, and D. So here, for example, we know those two are equal, vertical angle theorem. Okay, and then we know these two are equal, vertical angle theorem. So these are my interior angles. So it says the interior angles equals the average of their intercepted arcs. Well, this interior angle comes from the, and this one as well, comes from this intercepted arc and this one right here. So we add those two intercepted arcs together, divide by 2 because there's 2 arcs, and that's what average means, and that'd be the angle for the interior. So let's say this is 100 and this is 70 right there. Okay, so that means if I add 100 plus 70 and divide by 2, 170 divided by 2 is 85 degrees. That means both of these are 85 degrees. That's their interior angles, equaling the average of their intercepted arcs. Okay, well, now don't forget I have a linear pair here. So if that's 85 degrees, that means these have to be 95 degrees, so they form a linear pair, which means that they are adjacent angles that are supplementary, which means they add to 180. So 180 minus the 85 is 95 degrees. So that means whatever these two angles, whatever this arc right here is, plus this arc right here, has to add to 190 degrees, because 190 divided by 2 is 95. Okay, so just know that. So a DCAS, if they give you these two, they might ask for this right here, and so you have to get the 85 first and then do a linear pair to get the 95 degrees. So you do have to pay attention what they're asking for in the DCAS, which angle. Don't think I can't just jump right to that 95. I had to first solve for the 85 and then do a linear pair theorem to get the 95. Okay, next we have the exterior angles of a circle theorem. Exterior angle obviously means outside. So that's this angle right here we're talking about. It's called angle A. Put a B, C, D, and E right there. So what does that say? It says to calculate angle A, which is the exterior angle. Okay, so I'll just put angle A right there so you know which one it is. It equals the outer arc. Here's my outer one, the one furthest away, because we're talking about this angle, the outer furthest away, minus this inner arc right here. Okay, that's within that angle, angle A, divided by 2 equals this angle. So let's say this is 80 degrees, and let's say this is 200 degrees. Okay, so that says the outer arc, 200, minus the inner arc, 80, divided by 2 equals the measure of angle A. So 200 minus 80 is 120, divided by 2, divided by 2 equals, I was just thinking of the answer ahead of time, 60 degrees. So that would mean angle A is 60 degrees. Now another way of saying that is I want to go ahead and just double angle A. That's what this is, double the exterior angle. So 2 times the measure of angle A equals that outer arc minus the inner arc. Outer arc minus inner arc. Okay, so I don't care how you choose to memorize it. You can just do outer arc minus inner arc divided by 2, or I can do 2 times this exterior angle equals the outer arc minus the inner arc. Okay, now they just have to give you 2 of those 3. They can either give you measure of angle A, or in the outer arc, and you find the inner arc, or they can give you the outer arc, or the inner arc, and the measure of angle A, and you find the outer arc. Okay, or they give you both the outer and the inner, and you find the exterior angle. So they have to give you 2 of those 3, but then you have to plug in that equation. That's where your algebra skills come in and solve for it. Okay, so that's that one. And lastly, we have tangent to a circle theorem. We've talked about this before. We talked about all the different types of angles and segments and secants, etc., that deal with a circle. We talked about a tangent before. Okay, so this point D right there is called the point of tangency. That's where it touches, or line AC or line CA, where it touches the circle in one spot. That point of tangency right there is always at a perpendicular, also called a right angle, also called 90 degrees, to the center of the circle. It's only to the center of the circle. So let's say we call that circle P. So that segment PD is perpendicular to tangent line CA. Okay, always 90 degrees. Okay, that covers this topic and what you need, or this lesson, lesson 6 of it. and what you need to know. 10 minutes.